Hello, today we're going to talk about periodic trends, and these are different properties that have kind of a pattern across the periodic table. So they change in a particular way as you go down a group or as you go across a period. All right, so the first one that we're going to discuss is atomic radius. So the atomic radius is just like what it sounds like. So in math, the radius is the distance from the center of the circle to the edge, right? In chemistry, that means that we're talking about the distance from the nucleus to the valence electrons, which are essentially the edge of our atom. So that's our atomic radius. And as we go down a group in the periodic table, we continually add new shells of electrons or additional energy levels. So our radius is going to go up as we go down the periodic table. The one that's a little trickier is as we go across the periodic table. So as we go across, the number of shells remains constant. So this would be like our second row in the periodic table. So the number of shells is constant. But we're adding protons to the nucleus as we move across. So as we add more protons, the attraction between the center and the outside gets stronger, and so the radius actually goes down as we go across the periodic table. Right? The next one we're going to talk about is ionization energy. Ionization energy is the amount of energy that is required to remove an electron from the atom. So we're going to be removing the one that's on the outside, so this would be a valence electron. As we go down the periodic table, that valence electron gets further and further from the nucleus. All right, so it's not going to be held as tightly. So remember, our electrons are negative, and the center of our atom is positive. And so we have an attraction there, right? So as we go down the periodic table, the ionization energy will go down because it gets easier to remove an electron, so it doesn't take as much energy. And then as we go across the periodic table, that attraction that I was talking about from the protons in the nucleus is going to get stronger, so it's going to get harder to remove an electron. All right, the last one we're going to discuss in this lesson is electronegativity. So electronegativity refers to atoms in bonds, okay? So you'll notice that on my list here, I have taken off the noble gas at the end because they don't typically form bonds, so we don't talk about electronegativity with those. So electronegativity is how likely an atom is to pull the electrons toward itself when it's in a bond. Okay, so this is going to be directly linked to the ionization energy, right? So just like an atom can hold on to its own electrons, it will be holding on to somebody else's electrons when it's in a bond. And we'll talk more about bonding in the next unit. So as we go down, those outside electrons, which is where the bonding happens, get further away, and so the electronegativity will decrease. The atom's not going to be as good at pulling the electrons toward itself as they get further away. Right? And then if we go across a row, the electronegativity increases because the protons in the nucleus goes up, and so we have more charge pulling those electrons in. So on your periodic table, fluorine is going to be the most electronegative atom because we're ignoring that column of noble gases. All right, so now I've gone over the three different properties that we're going to talk about for periodic trends, and I want to just review one more time the factors that affect those trends. So I mentioned them when I talked about each thing, but just to make sure that we're clear. So first, just a review of Coulomb's law. This is, the word might be new, but the concept shouldn't be new to you. This is basically that opposite charges attract and like charges repel, and that as the distance between the charges increases, that attraction or repulsion will decrease. So the further apart two charges are, the less attracted or repelled they will be, and the closer together, the stronger that attraction or repulsion will be. Okay, and if the magnitude of the charge goes up, then the attraction will also go up. So let's talk about what that means in terms of our trends. So in the last lesson, we talked about effective nuclear charge, and you saw that as we move across a row or a period, the effective nuclear charge goes up. And that is because so in this row here, our core electrons remains 2 the whole way across, right? But we're adding in protons, okay? So our shielding doesn't change, but the protons in the nucleus increases, and so the pull that these outside electrons, valence electrons, will feel will increase as we go across. And that's the reason that the atoms get smaller, and then they get more electronegative and have higher ionization energies as we move from left to right. Okay, the other factor is the number of energy levels. So as we increase the number of energy levels, we're increasing the distance between those outside electrons and the nucleus, all right, which means the attraction will go down. Okay, so this causes, so more energy levels means a larger radius. It means a lower ionization energy because it gets easier to pull those off as they get further from the positive charge in the nucleus, and it means a smaller electronegativity. All right, so take just a minute and summarize those trends on the periodic table that I've provided you on your notes so that you have those as a reference. And then keep in mind that while knowing what the trends are is important, it is more important to me that you can explain why the trends are what they are using the energy levels and the effective nuclear charge as reasoning.